Hi friends, how are you? So today I am gonna discuss about batch, mini batch and stochastic gradient descent, and I'm gonna show you some code related to that. So first of all, why we need optimization? Actually, we need optimization to improve accuracy and to reduce loss. So how it is done? It done with the use of this hyperparameter changing. So uh, changing in the weight, updating that weight, and by changing the learning rate. So the main target is we are changing learning rate and we are updating our weights here. So let's say first how to import some libraries in this. So for this purpose, what we need to do, we first need to uh, import some libraries from I have imported this library from sklearn, some data set from sklearn, numpy, pandas, and matplotlib. So these are basic libraries that used with working in a machine learning algorithm. So these are as per requirement. So first of all, what I'm going to show you here, I'm going to show you three algorithm with the help of iris dataset. So let's say you first need to load this data set. So this is iris data set, and we are doing dataset dot load iris. This is a well-known function that how to load data set in this. So first loading data set by dataset dot load function, and x is equals to iris dot data uh, of 0 to 99 comma this null to 2. So why we need this? For convenience purpose, we select first two features. This is showing that we are selecting first two features, and this is showing that we are taking 0 to 99. That means 100 records with first two features. All right. So this is data set, and in y level we are this y hat is our y level in which we are taking iris dot target. So we are also taking our 100 targets because 100 features we have taken. So that's why we are taking corresponding 100 labels with respect to each sample. So that is also called ground truth. And then I am using this batch gradient descent. What happened in batch gradient descent? We are sending uh, data in a batch size. So it's okay. So let's say you have a function. We are making a function of batch gradient descent, and here we are defining a learning rate and number of iterations x and y hat. Then in first step, what we are doing in first step is our initial step. So initially we are defining some parameters like length, n is equals to length of x, w is equals to n dot zeros. So this is numpy array of zeros with x shape. And then we are, because this weight and bias we need to take, so is in starting bias we are taking as 0, and we are taking this cost equals to and this cost equals to null array. Okay, so and then what we need to do, we need to start this loop for I in range in number iteration. That means we are doing some loop functions, and in this loop function we first apply sigmoid functions and get by predictions. So this is a way of applying the sigmoid function. First we are taking a linear equation wt comma xt plus b, that is equivalent to mx plus c. So here we are taking wt comma xt dot plus b. So this is a well-known functions of equation, linear equation. Then we are giving this linear equation in this sigmoid function. So our formula was like 1 upon 1 plus 1 upon 1 plus 1 upon np dot e to power z. So that will be your this thing. So it's a easy function. You can check here. Then we are calculating loss functions using cross entropy loss. So this is a well-known functions for cross entropy loss. So from here we are calculating cost, in which you can you I think you know this formula of cross entropy loss. Then we are calculating gradient. Calculating gradient is also an easy step. Here we are doing some average functions. Then we are updating our weight and bias. So how we are updating our weight is equals to w minus learning rate into dv, and bias is equal to b minus learning rate into db, and we are record cost. So this is a statement for recording this cost, how much cost we are applying for this. So if I is module via this 1000, it means if remainder is 0, equal to 0, that it means we are appending this cost. Otherwise we are not appending this cost, we are returning just weight, bias and the cost. Okay, so and then we are running a function for batch gradient, for this batch gradient that we have seen this algorithm. Okay, so this here we are calling with the help of learning rate of equals to 0.01 and number of iteration of equals to 10,000, sorry, 1 lakh, and then x is equals to x that we have already given, and by is hat is equals to by hat. So in this way we are calling batch gradient function. So you can check, this is a function from scratch for this batch gradient descent. And then stochastic gradient descent. So in a similar way, for stochastic gradient descent, we need to define a stochastic gradient, and same way learning rate, number of iterations, x and y hat, and need to initialize parameter. So we are initializing n is equals to length of this x that we are giving, and in a similar way that numpy array of g starting with zeros, and then we are doing some shape function, and then bias a cost, and starting with starting two layer of loops. So here, because we are doing batch gradient descent, so that's why we need two loop. So for this for I in a range, number iterations, and for j in range n, so how many iteration we are doing, and for how what range we are doing, because there we have batch also now, out of all data set. That's why. So choose one record, one by one we are choosing record. So we have choose one record, and we are taking it as y equals to y hat, and we are then applying a sigmoid function, and we are getting a by prediction. So here you can also check that. Okay, so how to do how this sigmoid function. So this the sigmoid function is in the similar way that we already have done in the previous step in batch gradient descent, right? So here we have done this, and we are calculating this sigmoid function, and we are calculating loss. After that we are calculating gradient, and then we are updating our weight and bias. Here the thing that is different from the batch gradient descent is, while calculating loss functions, so we are using this loss functions for batch gradient descent. So f full is equals to np dot this equation, linear equation we are given as child full, and by prediction of full is equals to that uh, sigmoid functions here, and then cost we are calculating by using this cross entropy loss, right? And here we are appending the cost, and then we are uh, calling this stochastic gradient descent. So this is about stochastic gradient descent, and in this way we are calling this stochastic gradient descent. Okay, and then after stochastic gradient descent, We are calculating mini batch gradient descent. So mini batch gradient descent means we are creating a small patches, a small batch of this complete data set, and here functions you theory. I'm not saying the theory here, I'm just showing the code. So this function of mini batch gradient descent is like first start with of defining with the functions of mini batch gradient descent with the learning rate and a number of iterations. If you would like to know the theory behind it and the numerical calculation behind it, then just prefer my another video that is also available in my YouTube channel, so you can check there. So there I have explained all the theory behind it and all the mathematical things behind it. All right. So first, what we are doing for this mini batch gradient descent, we are defining a mini batch gradient descent by learning rate, by number of iterations, x, y hat, and mini batch. In a part one, what we are doing, we are defining our mini batch, in which what size of batch we are taking. So this is a np.random.seed and n equals to length of x and then mini batch. Now we are shuffling this x and y. So we are taking a permutations is equals to list of np.random permutations of x and then shuffled x equals to x of permutations comma uh, complete set we are taking here, and shuffled by is equal to by hat of permutations. And then we are doing after shuffling we are doing partitions. So for partitions num complete mini batch is equal to this int np flow dot one n divided by mini batch. So I would rather prefer first go to this some videos about this mini batch. Then this is very easy to understand this step what is happening in this step. So this is just all code from scratch. Okay, so first loop we are running for this I to range of num complete many batches, and then by some shuffling we are taking this mini batch x with some data set, some records, and in mini batch y we are also taking some records. So in this way we are doing this mini batch equals to mini batch of x comma mini batch of y. Mini batch dot append mini batch. If n multiplied by mini batch is not equals to 0, it means if this condition is of this condition is satisfied, that means if it is not equal to 0, then we'll go to this step, and this step is about mini batch of x is equals to shuffled x min n minus mini batch and this. So they are just uh, appending a mini batch based on some set conditions. And then in a part 2 we are again doing gradient descent. So for gradient descent, what is happening, taking this array of zeros and some initial bias, initial cost, and until there is a number of iterations. So for this range of number of iterations we are running another loop for this, and for j in range complete mini batch plus 1, we are first selecting mini batch and then apply sigmoid functions and get by predictions. So this is a way of getting the by predictions, then calculating the gradient. So I think now it's quite clear because we have seen two algorithms before, and then we are updating our bias and weight. So then we are calculating loss here in a similar way that already in previous algorithm in the stochastic gradient descent algorithms, and then we are appending this cost and returning this w and like weight, bias and cost. Then this is a function of running this mini batch gradient descent with learning rate, number of iterations, and mini batch size. So if you see, this is the result from batch gradient descent, stochastic gradient descent, and mini batch gradient descent. So this is a weight bias for batch gradient descent. Let me increase font size. Okay. So this is weight and bias, and for this batch gradient descent, and the another algorithm is stochastic gradient descent. So then there is a weight and bias for that algorithm, and again there is a weight and bias for mini batch gradient descents. So I hope this algorithm is quite clear. This code is quite clear, and thank you.